Hello everyone. So for today, I will be discussing the different types of sorting. So first is insertion sort. Insertion sort is the sorting mechanism where the sorted array is built having one item at a time. So we need to select the first unsorted element, then swap the element to the right to create the correct position and shift the unsorted element. Last is advance the marker to the right one element. For example, we need to select the unsorted element which is number 4. So we swap 4 and 6, then advance the marker to the right one element. Next is we need to select unsorted element which is number 2. So we swap 2 and 6 and 2 and 4. Then advance the marker to the right one element. Lastly is we need to select the unsorted element which is number 1. So we need to swap 1 and 6, 1 and 4, and 1 and 2. So finally, the array is now sorted. Next is quicksort. Quicksort is a highly efficient sorting algorithm and is based on partitioning of array of data into smaller array. This sorting algorithm uses the idea of divide and conquer. It finds the elements called pivot, which divides the array into two values in such a way that elements in the left half are smaller than pivot and elements in the right are greater than pivot. We recursively perform 3 steps. So first is bring the pivot to its appropriate position such that left of the pivot is smaller and right is greater. Second is quick sort the left part. Third is quick sort the right part. For example, counter variable I, index of smaller element. J is loop variable. So pass 1, we start the loop with initial values. 20 is greater than 70, which is true. So swap the array I and array J. So the value of I is equals to -1 and J is equals to 0. So pass 2 is 80 is greater than 70, which is false. No action, and value of I is 0, J is 1. Pass 3 is 30 is greater than 70, which is true. So swap the array I and array J. So the value of I is 1 and the value of J is 2. So pass 4 is 100 is greater than 70, which is false. No action, and the value of I is equals to 1, J is equals to 3. Pass 5 is 50 is greater than 70, which is true. So swap the array I, then the array J. The value of I is equals to 2 and J is equals to 4. So pass 6 is 60 is greater than 70, which is true. Swap the array I and array J. The value of I is 3 and the value of J is 5. Before pass 7, J become 6. So we come out of the loop. We know the swap array I plus 1 and the pivot. Now that 70 is brought to its appropriate position by the partition function, we can begin quick sorting the left part. Next is heap sort. Heap sort is a comparison-based sorting technique based on binary heap data structure. For example, first we build the heap using the given element. Now that we have built a heap, we need to transform it into a max heap. We create a max heap to sort the element in ascending order. In a max heap, parent node is always greater than or equal to child node. 12 is already largest. 12 is greater than 3, so we swap 3 and 12. Next is 7 is greater than 3, so we swap 7 and 3. Once the heap is created, we swap the root node with the last node and delete the last node from the heap. So first node is 1 and the last node is 12. So we delete the last node, which is 12. Next is create a max heap. So the last what I've said earlier, max heap parent node is always greater than or equal to child node. Next is swap 1 and 3, then swap 1 and 7. So the first node is 1 and the last node is 7. So we delete the last node, which is number 7. Next is create a max heap. So swap the 3 and 1, then swap 2 and 3. So the first node is 2 and the last node is 3. So we delete the last node, which is the 3. 2 and 1 is already a max heap. So only one element left in the heap. So this is how we end the algorithms. Next is radix sort. Radix sort is one of the sorting algorithm used to sort a list of integer numbers in order. For example, we sort the numbers from least significant digit to most significant digit. So we use counting sort as a subroutine to sort. This is an input array. First, consider the ones place, which is 0, 0, 3, 9, 0, 2, 5, and 6. So we observe that 180 has come before 89. This is because it appeared before in the original list. Now, consider the tens place, which is 8, 8, 0, 2, 4, 7, and 6. Now, consider the hundred place, which is 8 and 1. Next is we sort this array into smallest to largest numbers. So 5, 22, 40, 66, 73, 89, 180, and 800. So array is now sorted. Lastly, merge sort. Merge sort is a sorting technique based on divide and conquer technique. For example, these are the sorted array. We have to sort this array using by merge technique. What is merge technique? So we have to divide, after divide, conquer recursively, and combine. So we need to combine this array into two halves. And same this another half. Now, I divided the array into two halves. Same also here. So, this array of size n by 2, this is n by 2, n by 4, and so on. So, this array divided into 2 and a half. So, this conquer recursively, which all elements come to size in 1. Now, combine the array by sorted. Just combine these two array into smallest one. You can combine the array by solving the problem, that is the merge sort. So this is the technique of merging array. Next is we have to merge into two arrays by solving the problem. So this is how to do the merge sort.